one is a simple assembly program where you will find the greatest element of the array and then return its index. So here we have the high version. So if we take a quick look at this, we have our array, and then we have a variable containing our maximum number and our maximum index. So the target in this case is going to be our maximum index. And then we loop through the array and find the maximum and the maximum index, and that's it. If you take a look at the low version, very similar. It's pretty similar to what we did last week, actually. We loop through the array with this while loop. Here's the conditional of the while loop, this part. This is the inside of the while loop. This is the mechanism for going back to the beginning. And so inside the while loop, we see an if. That is this if, where we're assigning the maximum value and maximum index. And then finally, you have your assembly file. In your assembly file, we gave you your array and the result. So your result is going to be in 285, where you will report the greatest index. So in this case, for this array, let's see, the greatest element is, I believe, 99. So 99 is in address 122, and your array starts at 100. So 122 is your 22nd index. So the result inside 285 will be 22. So all you have to do is actually just convert this into assembly. Okay, any questions regarding this? Okay, I don't hear any questions, any comments.
Actually, I have a question. Can you show how to access the array elements?
Okay.
I didn't understand from videos.
Okay, we can do that. So say we have our array at 100. Let's say 9, 101 has 8, and let's just keep it 2 elements. Let's put our size in here, 2. This is our size. This is a 0. This is a 1. So in order to access this element, let's say a 0, we're going to have an index. Let's put that in 50. So 0 right now. This is my I index. And let's have a temporary in 51. So let's call this temp1. All right, I think that's it. So here, let's do temp1 is equal to a0. Okay. So in order to do that, I'm going to have to find the address here. So we should also have a start of array, right? So start of array is at 100. So this is start of a. And let's actually put this up here. This is our objective. Let's see how we do this. So the first thing I need to do is find the address that I need to get the element from. So in this case, the address is 100. So how I do this is, let's have a temp1 and temp2 here. 52. I'm going to first copy the start of my array into my temp. So 51 and 98. So this is temp1 is equal to start of A. Next, I'm going to add my I here. So let's actually do it like this. Add 51 and I is 50. So now this is temp1 is equal to temp1 plus I. So regardless of what my I is, now I have the address that I need to find. So if I were to loop back into this place, this would also work for 101 if I increment I by 1. All right, so next up, I'm going to use this address to read it. So let's actually put this in temp2. CPI, the first I put the place that I want to, the address that I want to put this into, so temp2, this case 52, and then the address that I want to read from, so 51. This is temp2 is equal to star temp1. So,
sorry, what is the benefit of 52 temp2?
So, I mean, you could just say this as well. This is fine. I just want to separate them. Is that okay?
I don't understand.
So I just wanted to put this in somewhere other than temp1. That's why I said temp2. But I could have easily just done this.
I mean, why are we using it?
Did you not ask about how to read arrays, how to access arrays? So right now I just read an element of array and put it in my temporary.
Okay.
Okay, so let's actually keep it like this. So this was actually how to read the array. So in this case, let's do something like this. Let's say AI plus 5. Let's find AI plus 5, which is fairly simple. I'm going to use the temporary here, the temporary 2, because that's where I stored my elements. So add I 52 5. So this is exactly this actually. And this is inside temporary 2 right now. And then finally, I want to write this back to the array, right? So that would be something like this, right? AI is equal to temp2. So the way I do this would be CPII. So I already have my address in 51. So 51. And then the value that I want to copy is in 52. So 52. So this is AI is equal to temporary 2. So now I read my array, I modified it, and then wrote it back. So this is actually how you access your array.
Thanks.
Okay. Anybody else has a question about this? Okay, so I guess everyone else understood how to write into arrays, read from arrays. So, okay, let's go back to this. Any questions about this assignment? So in this case, you're going to read the array and then you won't even need to write back. So it's actually pretty simple. Okay, then let's keep going. So we're done with this. Let's go into part 2. So in part 2, you're going to write a program that counts the number of different bits between two numbers. And the way you do this is you're going to use two functions. And we've already actually given you these functions. All you need to do is call these functions. So let's actually look at the assembly file and talk from there. So here we've given you two functions. The first one is a XOR function, and the second one is a function which counts the number of ones inside a number. So by number of ones, I mean when you convert it to a binary, this function counts the number of ones in that. Okay. So all you actually need to do is call these functions and then see how this works. So actually, I have a explanation of this in our video as well. So I'll try to keep it brief here. So we're trying to find the different number of bits in here. And the way we do that is we have number A and number B, let's say. The first thing you're going to do is take the XOR of these two. So XOR A and B. And let's save the result of this in, let's say, X. And then the result will be count ones of X. And why does this work? Because if you take the XOR of something, if the two bits are the same, you get a 0. If you get if the bits are different, you get a 1, right? So let me actually find a truth table of XOR. XOR truth table.
You're not showing the browser.
Okay, give me a second. There we go. So the XOR is something like this. So when the two inputs are the same, oops. So when the two inputs are the same, you get a 0. So 0, 0 is 0, and 1, 1 is a 0. When you do different inputs, you get a 1. So 0, 1 is 1, and 1, 0 is 1. And the function that we gave you is a bitwise XOR, meaning the function will do it for every single bit in the two numbers. So if it was something like this, well, let's keep it simple. It'd be something like this. So these are the same, so they will be zeros. And this is different, so 1. This is same, so this is different. So it ended up being the same as the second one, but let's say I had 1 here, this would be 0. All right, and then you're going to count the number of ones inside this, which is in this case going to be 1. And if you look at this, the only different bit in these two numbers is actually this. So that is our expected answer. And let's look at our file again. Here we go. And this is our file. So if you don't have any conceptual questions, let's talk about how to use functions. So any questions regarding this part?
It says fill in. Where are we filling?
This part. So you're going to start from address 0 and start to write the program here.
Okay.
So if we don't have any other questions, again, I'm going to make a brief explanation of how to call functions. Again, I have a more detailed explanation in the lab video, so I'm going to try to keep it brief. All right, so we've actually given you a picture, I believe. Let's see, oops, that's lab 2, lab 3 is here. They've given you a picture from one of the previous lectures that Fatih Hoca has given. So this is actually how you use a function. So the first thing you do is copy your arguments. The second thing you do is write the return address, jump to the function, execute the function, and return to return address. So let's take a more detailed look at this in here. So I'm just gonna put this somewhere else. So let's say I have a function at 100 and it does something very simple. Let's keep it simple. So I'm going to first write it, then explain it. So let's say 150, no. So let's talk about what's going on here. So, okay, let me actually write this part as well. 0, T, 1, 4, okay, so let's talk about what's going on here. So what I'm actually doing here is, so this part is my function. And this function takes one argument and returns one other argument, let's say integer in this case. And let's see what's going on here. So the thing that it's doing here is copying the argument into a temporary value. So temporary is equal to a. And then this function takes this argument and adds 5 to it. So temporary is equal to temporary plus 5. And then it writes this in its return value. So return is equal to temporary. And then it goes back to what we call return address. So go to return address. And I'm going to talk about this return address in a bit. So let's talk about these variables here. So this is the start of function. This is my a. This is my, let's see, this is my return address. This is my return value. So in this case, just ret. So I quickly wrote those down. So this ret is here. Return address, the one I jumped to here, is here. And the A is this one. And what's happening here is I'm writing a value into the A value here. So A is equal to 3. And then here, what I'm doing here is return address is equal to 3. And then go to function. So this is something like fa, calling a function, this part. Well, actually, the entirety of this is calling the function, but you can think of this as the end of it. Okay, so let's actually talk about return address and return value. So the return address indicates where the program will return to, come back to, after the function is done. So as you can see here, I go to the function here. So it goes from 0, 1, 2 to 100. So I start executing the function here. And once the function is done, it will return to wherever the return address is. So in this case, it is 3. So I will go back to here after the executing function and continue on the program. And the return value, so return value is defined here. So if I wanted to reuse the return of this function, I could use 51. So let's actually call this 51 is equal to this. So if we were to take a look at our steps once again, so step 1a is here. So I copy my argument. So let's do this. I copy my argument. Step 1b, I wrote my return address. Step 2, I jump to my function. Step 3, I execute my function. And then step 4, I return to my return address. So that is actually the end of the function. Once this is finished, the program will continue on. So, any questions regarding functions? No?
Burada it says step 1a copy arguments. Is it the line in 15?
No, it's the line in 0. So I'm copying my desired argument, so desired value into my argument. So, and by argument, I mean this. So say like this. So I'm copying the value into this A here.
Okay. Our and other question is our return address should it be always 0 or something else?
So the return address isn't actually 0. It's defined as 0 here. I'm changing it here, right? So the return address is wherever you want the program to continue on. So in this case, after the program finishes, I want it to continue doing this part. So that's why it's actually 3.
Okay. Okay.
Okay, well, if you're not going to ask a question, I just remembered something. So what if I have a function like this, which you're going to have in your lab? So this is fairly simple. All you need to do is have another instruction here. It's fairly similar to the other one. So let's say my B is in, what did I not use? So 53, 53, I've got 53, and I put some other value in here. So in this case, b is equal to 7. And of course, now this is going to be 4.
Can you explain how did you copy 1, 2, and 3 again? I
Okay.
have problems with that.
Yeah, that's, I can show you that. So I had it like this, right? So the way I did it is first I erased this, and then I'm holding down Alt and Shift, and then I'm pressing down, down, and then right, which lets me select all of these, and then Control X, Control V.
Thank you so much. Thank you.
So this is very useful, actually. I use it all the time. So you can't use it in Notepad, just you can use it in Notepad++. But
can you show all the tricks you use?
all the tricks I use. Okay. Let's see. What else could I show you? Do you have anything in specific, or?
I'm not sure. Just asking for any other functionalities.
Okay. Well, I can't really think of much, but let's say another way to use that Alt-Shift trick is you can do this, right? Alt-Shift and then down, 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 and then you can write something here, and it will write it to all of these as well. So you could use it like that as well. What else? Oh, this is very useful. So I press Control H to bring up my replace menu. So so the replace menu is very useful. So let's say I wanted to change this 53 into 153. Instead of going into, well, I only use 53 once, I think, though, right? So let's say this 50. I want to change this 50 into 150. So instead of going here and here, here, whatever, instead of doing that, I can do it from here, 50, 150, and this will replace all of them. This is very useful. And let's say I had something like this, though. So something completely unrelated. Let's say 775, I had the value 150. So how would I handle this? Let's see. So it's not 50. Okay, let's actually keep this 150 and see what happens if I execute this now. So if I say replace all, now this became 1150. So to prevent this, what you can do is say put a space here, space 50, and make this space 150. This way, it will not replace 150. What else? Okay, well, I can actually talk about this section here. So there are different search modes here. Normal, extended, and regular expression. So you might have heard of regular expression. It's actually very useful. But let's see, how can I show you regular expression? So I think I already have a Piazza post about removing all comments and such. But if you didn't have that functionality, what you could do is something like this. So all of my functions are after this, right? So what I can do is put this here and then say dot and then a star. And let's see, do I need a $sign here? Let's put a $sign as well and replace it with nothing. That removes all my comments. So let me actually explain what I'm doing here. So I'm saying replace this, and then dot means anything, any character, which will occur many times until the end of the line with nothing. So when I say replace all, this will replace all of the comments. So this takes some getting used to, but Google regular expression, if you want to learn more about it, it is very useful. I really recommend that you learn it actually.
Thank you.
Okay, I guess one last thing. So let's say you want to remove the comments in here, nowhere else. What you can do is select it, say in selection, and replace all. This will only apply the search to here. I think that's all I can think about right now.